Now I'm going to demonstrate to you how to use IBM SPSS to do the factorial ANOVA or two-way ANOVA. In this example, we have the yield of product that we are measuring on the left side. Then we have the two catalysts that we use to catalyze the process. We have catalyst C6 and catalyst C7. And the temperature at which the process takes place. So we have three different temperatures: temperature 1, temperature 2, and temperature 3. Okay, so we want to know whether the different catalysts would affect the yield, the different temperature would affect the yield, or is there any interaction between catalyst and temperature at affecting the yield that we are going to see. Okay. Interestingly, for this two-way ANOVA or factorial ANOVA, or even for repeated measurement, the assumption of normality is not very important. Okay, so we don't have to test for the normality of the data because the algorithm developed are robust enough to factor that out. So we don't have to bother about whether the data are normally distributed or not. So we are going to use under general linear model to perform this analysis. So I'm showing you how to do it now. So you click analyze, go to general linear model, click univariate. Okay, then transfer the yield, the dependent list, into the dependent variable and the independent variables into factor, catalyst, and temperature. Don't change model, maintain as type 3. Okay. Contrast also don't change. You can go to plots here. Okay. Here it will enable you to choose to see the individual effect as well as the interaction between the two factors. Okay, so you transfer catalyst into horizontal axis and click add, temperature into horizontal axis and click add, catalyst into horizontal list and temperature into separate lines and then click add. So now you have this factor, the interaction factor, catalyst times temperature, as well as the individual factor on how these factors are affecting the yield. So click continue. Post hoc, okay, because there are only two level of catalyst, two different catalysts used, post hoc is not required for that. But for temperature, we have three different groups. So that's why we need post hoc for temperature. So click temperature, transfer that to post hoc test. Okay, I would go for 2 key. So click continue, and then you can click option. All right, display overall, display catalyst, display temperature, and display catalyst times temperature. And we are going to compare the main effects. The main effects are catalyst and temperature. Okay, so click main effects. Then confidence interval adjustment, I would choose Bonferroni. Okay, that is my preference. Then you make, if you want the mean, standard deviation, whatever, you can click descriptive data. Homogeneity test is very important because we want to see the distribution of variances. And then effect size. So if you remember our lecture on sample size calculation, we are going to report the effect size here too. Click estimate effect size and then click continue, and then we are good to go. So now you can see that these are the tables produced. Okay, so you have the mean for C6 and temperature. Okay, 75, C6 at temperature 2, 74, C6 at temperature 3, 76. So obviously you can see the trend of 76 is higher than 74 and 75. Whether it's statistically significant, that's going to be, we are going to explore that later on. Okay, now you can see the leaving test of equality. Although the value is is significant, but it doesn't really matter because, as I mentioned, the algorithm is robust enough to compute all this. So we don't have to bother much about the leaving test of equality. So you look at test between subject effects. You can look at catalyst, okay, and the value is 0.343, meaning that catalyst is not significantly influencing the yield. It doesn't matter whether you use C6 or C7, the yield will not affect that much. Alright. And you can look at the ETA, this is effect size. So 15% of the changes is actually affected by catalyst. Right? So it's not very huge. It's only 15%. So temperature, on the other hand, is 0.0026. So temperature is a significant factor at influencing the yield that you are going to see. And then you look at the interaction between catalyst and temperature is 0.03. So this is also significant. So individually, catalyst does not significantly influence the yield, but when in combination, catalyst and temperature, that as a combination affect the yield, okay, significantly. So as you can see, for temperature, the ETA is 0.705, meaning that 70.5% of the changes is actually accounted for temperature, and 69.1% of the changes is accounted for the interaction between the two variables. So we know that individually catalyst does not influence. So now we go to catalyst. As you can see, C6 versus C7 is 0.343. It doesn't make any significant difference. Temperature, yes. If you look at temperature 1 versus temperature 2, it's not significant. Temperature 1 versus temperature 3, it's significant, 0.0028. Temperature 2 versus temperature 3 is also not significant, 0.241, right? And then all the other things are repetitive of the part that we have already discussed. Okay, and then that's about it. So what we can conclude is temperature is actually the significant factor that affect the yield that we are going to observe. Catalyst does not, it doesn't matter, but in terms of interaction, yes, they do have some significant effect in combination to affect the yield. So this is how we interpret the finding.